So today we're going to dive into a really clever engineering trick that totally changed how we clean our water. And the best part, it's not about more power or bigger, fancier machines. Nope, it's about a simple but super smart shift in thinking. Okay, to really get this, let's start with a question. Imagine you're running this massive banquet hall and it's filled with billions of hungry workers. In our case, they're microorganisms. Your one job is to feed all of them evenly and keep them happy. So how do you do it? Got that picture in your head? Good. Just hold on to it. All right, so first up, we need to understand the problem, right? Let's take a look at the old way of doing things. The problem this whole clever solution was designed to fix. This is what we call the conventional conundrum. So the standard method, the one we're trying to improve on, is called conventional plug flow. And it's pretty much what it sounds like. You take all the wastewater, that's the food, and you dump it all in at one single point, right at the beginning of a long tank. Then you mix it with something called return activated sludge, which is basically just a big, concentrated soup of our hungry microbes. And yep, you guessed it, this brings us right back to our banquet. The old conventional method? It's exactly like taking a mountain of food and just dumping it all right at the front door. And then expecting everyone, even the people way in the back of this massive hall, to get a fair share. You can probably see where this is going. What you get is a total imbalance. Right at the inlet, it is an absolute feeding frenzy. The food-to-microorganism ratio, engineers just call it the FM ratio, is through the roof. The microbes are totally stressed out and they're sucking down oxygen like there's no tomorrow. But by the time that water gets all the way to the end of the tank, all the food is gone. The poor microbes back there, they're starving, they're barely active, and the oxygen demand just tanks. It's a system of wild extremes. So how in the world do you solve this feast or famine problem? Well, the answer is just beautifully simple. You just have to spread the load. Let's go back to our banquet hall. Instead of that one giant food mountain at the entrance, what if you set up several serving stations all along the hall? That way, everybody gets fed, from the people at the front of the room all the way to the folks in the back. And that right there is exactly what the step feed process does. It takes all the incoming wastewater, our food, and instead of introducing it all at once, it distributes it at multiple different points, or steps, all along the aeration tank. I mean, it's such a simple change, but believe me, it changes everything. This table just lays it all out, nice and clear. Conventional flow has that one single entry point, which causes those crazy high and low FFM ratios, and that huge oxygen spike right at the start. Now, look at step feed. With its multiple points, you get a stable, uniform ratio and an even, constant oxygen demand. The word you're looking for here is balance. So here's how it works, step by step. All of the microbes, the sludge, they still come in right at the beginning, but the food, that primary effluent, gets split up. It's then introduced at different steps along the tank, and the result? You get this perfectly balanced, happy, and way less stressful environment for our billions of tiny workers. Okay, so we've got balance. Big deal, right? Well, yeah, it's a huge deal. The benefits are massive, and they affect everything from how stable the system is to how much it costs to run. The first major win is that it's a champion at handling what engineers call shock loads. Just think of it like an unexpected busload of super hungry guests suddenly showing up at our banquet. In the old system, that would completely overwhelm the front door. But with step feed, that sudden rush of food is spread out across the entire system. So the whole population of microbes pitches in to handle it. This makes the whole process so much more stable and resilient. Second, you get much healthier sludge. See, that stable environment stops certain kinds of stringy bacteria from growing out of control. When they do, it causes something called sludge bulking, which is a total operational nightmare. It's where the microbes get so fluffy they won't settle down, making it super hard to separate them from the clean water. So with step feed, you get happier microbes, which means a healthier process, and ultimately cleaner water. And this chart, it illustrates the third big win perfectly, saving energy. Pumping oxygen into these tanks is one of the single biggest energy costs for a treatment plant. The old conventional system needs a massive amount of oxygen right at the start to deal with that feeding frenzy. But step feed, it has a much lower, uniform demand. This smooths out the energy use, saving a ton of power and, you guessed it, a ton of money. Now, this all sounds great in theory, but where is this actually being used out there in the real world? Let's take a look.
Well, step feed is an absolutely perfect choice for big city plants that just have to be robust. It's also an incredibly smart way to upgrade an older plant. Instead of building a whole new tank, which is crazy expensive, you can often just add a few pipes to convert it to step feed and boost the plant's capacity in a big way. It's also perfect for places that treat industrial waste, where the amount of food coming in can be all over the place.
And here's the kicker. This is what makes the design so incredibly clever. Its flexibility. If, for whatever reason, an operator needs to switch back to the old conventional method, they can usually do it just by turning a few valves. It gives them amazing control to adapt to whatever conditions come their way. You know, when you boil it all down, the lesson from the step feed process is really powerful. The best solution wasn't a bigger pump or more energy, it was simply smarter distribution. And that kind of leaves us with a final thought. What are the really complex problems out there, maybe in supply chains or even data networks, could be solved not by just adding more raw power, but by just being a little bit smarter about spreading the load?